Hello, I'm Manuela Saragosa. Welcome to In the Balance, the discussion programme from the Business Daily team that takes you behind the news. OK, let's try that again. Hello, I'm Manuela Saragosa. Welcome to In the Balance, the discussion programme from the Business Daily team that takes you behind the news. Now, don't worry, they haven't replaced me with a robot yet. This week is European Robotics Week, which means lots of exhibitions and talks about the subject across the continent. Improved technology is pushing robots into almost every aspect of our society and economy. The Curve report, an American-based survey of trends and insights, found that advocates of robotics argued it could create more than 3 million new jobs globally by 2020. But others argue robots will simply replace jobs done by humans. So our question this week is, can robots happily coexist with people? I went along to an exhibition called RobotSafari in one of the cavernous rooms at the Science Museum in London, which is showcasing robotics inspired by the natural world. And I went to see how far along the road we are, technologically speaking.
My name is Richardson. I'm with Tallinn University of Technology, Center for Biorobotics in Tallinn, Estonia.
And we're standing in front of your creation, one of the projects you've been working on, which is a small robot, yellow. It looks like a small spaceship, no more than 0.5 metre in length, and it has green flippers attached to it. 4 green flippers attached to it.
This is a robot called UCAT. It's underwater robot developed for underwater archaeologists. It will go autonomously inside shipwrecks, take video footage inside the shipwreck, and then come back to the surface for the archaeologists to get the video data and analyze it.
So essentially it's replacing a human diver?
Yes, because diving is not only just expensive, it's also very, very risky for divers. It can go inside a shipwreck, inside a hole in hull. It can see what's inside and decide for itself where it will go and how it will go back. Not more. It won't rule the world.
I'm Helge Wurdemann. I'm working for the Center for Robotics Research at King's College London, and I'm part of the STIFLOP project, which is funded by the European Commission. We've
got a sort of plastic version of a human body here, part of a torso, and an arm, a robotic arm stretching over it. So at the end of this robotic arm, there's a kind of plastic contraption which goes inside, and it looks like, it does look like a sort of octopus tentacle, because it stretches, doesn't it? And you can make it longer.
It does. We try to enhance laparoscopic surgery, keyhole surgery, as it is performed nowadays. They use rigid laparoscopic tools to be inserted into the abdomen.
So the point is yours is much more flexible and bendable, and it would make it easier, presumably, to operate.
Indeed, and there's where the octopus comes in, because the octopus doesn't have any backbone. It's entirely soft, but at the same time it can kind of jam its muscles. So whenever needed, it can go from soft to completely stiff.
Okay, that's why you've called it stiff flop. I can see.
Yes, that's correct.
I was talking to Helge Wurdemann and earlier Yuri Gavshin at the Science Museum's RobotSafari Festival, and that should have given you just a flavour of some of the research going on in robotics at the moment. But let me introduce our 3 guests who are going to discuss some of the issues raised there. Dr. Kathleen Richardson is a social anthropologist at the University College of London. She joins us from our Cambridge studio, though.
Hello.
Kathleen, you have a special interest in robotics. How so?
As an anthropologist, I'm interested in how contemporary society imagines robots. So I study robots in scientific labs, but I also study robots in fictions. I study the imagination of them in workplaces and how they'll be used and what they tell us about ourselves and what we think about being human.
And here in the studio we have Jeremy Wyatt, who's a professor of robotics and artificial intelligence at the University of Birmingham. And you spend your day presumably surrounded by robots. So you must like them.
Yeah, I guess I like people as well. But mostly what I'm interested in doing is actually developing programs or algorithms or software to make robots smarter. So it's things like how to get robots to see objects, how to get robots to make decisions, plan future courses of action, be autonomous, essentially trying to put the smarts in.
And from Manchester, we're joined by Geoff Pegman, who's Managing Director of RU Robots. Geoff, tell us what the company does exactly, RU Robots.
Okay, I mean, what we do is we develop robot systems for other companies, for bigger companies, anything from nuclear decommissioning through food industry through to medical robotics.
So let me start with you, Geoff. What can robots do today? Which sectors of the economy or of life generally are they most used in?
Well, the traditional ones are the ones used in the factory, and those are typically the things like the car industry, like developing, like the electronics industry. And then you've got the ones outside of the factory, and those are being used in all sorts of new areas, big ones being things like agriculture and surgery.
And are we at a stage yet where mass production of many of these robots is possible?
Well, I mean, the industrial robots, yes. I mean, we're selling some 150,000, and even on the domestic side, very, very simple robots like your vacuum cleaners, they are being sold in millions. But if you're talking about complex robots for the home, we're a little way off that.
Jeremy Wyatt of the University of Birmingham, we were hearing there from the Science Museum that one particular prototype that they were developing there, it took 3 years to make that prototype. Presumably it takes a huge amount of time and a huge amount of money to even get to a place where you can start thinking about mass producing some of these robots.
Yeah, I mean, it's particularly difficult if you're looking at, a technology where you're trying to get high reliability, and particularly if it's high reliability in an unstructured environment. So if you've got a robot in a factory, clearly you want it to be reliable, but also you can go in there, you can shut down a bit of the production line, or you can repair it overnight. Whereas if you're sending out a robot to a granny in a house somewhere to help her look after the house, then that robot's going to have to be a lot more reliable, and it's also going to have to be a lot more complex. I think autonomy is particularly difficult, because the thing is, as soon as you make robots autonomous, you also make them quite unpredictable.
In what way?
In the sense that it's very difficult, because the robot can be quite complex and its environment can be quite complex. And then what happens is that the way that the robot and the environment can interact, the situations the robot can get into, the variety of those situations is huge. So it's very difficult to reason as a designer about all the places that might end up in. And if you're going to put something out as a product, you need to be able to say to your customer, I know that my robot's not going to turn around and do something really crazy.
What I found quite interesting, again, at the Science Museum, is that particularly this robotic arm, the octopus arm that can operate, that it's capable of learning, that it's capable of knowing its way round the inside of a person, so that it can actually learn and operate more autonomously. In a way, quite scary.
It is and it isn't. The thing is, actually, if you look at... so artificial intelligence has crept into our lives in all kinds of ways. So we think about it as being scary because as soon as we say learning, we think about the robot as being cognitive and therefore conscious, and all of these sort of narratives that we want to impose upon robotics, which Kathleen can talk about much more knowledgeably than I can.
And we will get to that.
But actually, the learning can be very, very simple, and learning is going to be critical. Getting learning robots is going to be critical to get reliability. If you want robustness, if you want the robot to cope with new situations, you have to get it to learn, to even do the most mundane tasks, like picking up the cup of tea that I'm currently staring at.
And Kathleen, Jeremy touched on some of the points that I wanted to talk to you about as well, though. But should we be worried about the extent to which robotics has entered our lives?
I think the clue is in the word artificial intelligence, because I think people are assuming artificial intelligence is human intelligence. And sometimes, when we build robots and they speak back to us and act in ways that surprise us, we think, oh, they must be intelligent. But you've got to remember that actually what's going on is a very, very simplified model of what human beings can do. So simplified, in fact, that when the robots are doing things that appear in a certain way, it's a very distorted sense of being human. So in a factory, a production line, for example, most robots are designed to do a very specific kind of task. If there's any change in that environment, it can't carry out its practice. All they are representations and models of what these scientists and these researchers believe human beings are doing, and therefore designing those models and putting them into machines.
Geoff Pegman, what do you say to that?
Yeah, I tend to agree with that, but I think one of the things that is important here is that where we are moving to is actually getting robots and people to interact much more closely.
Is the idea eventually that you get these robots to do the jobs that humans are doing, that you want to eliminate the human?
Not to eliminate. I mean, to be quite honest, the easiest jobs to put robots into are those dull, repetitive jobs that people really don't want to do. And what we're going towards is actually getting robots to work with people so that the people can put in the skill element and the robots can put more of the drudgery in. I mean, the best example probably is in terms of robot surgery, where robots can do quite skilled, precise actions at the cutting end, if you like, but the surgeon is still using his skill to actually decide how that robot should actually operate.
This is very interesting because you're putting it all into a very positive light, and I suppose most people see sci-fi films and robots turning on their human controllers, that sort of thing, and get carried away with that. But one thing that struck me this week was that there was a BBC documentary featuring Amazon, which suggested that workers were being made to work in its warehouse like robots. These pickers who were there collecting the orders were on timers, they were expected to perform with the efficiency of a robot. Don't we come into a situation now where, because we have robots that can do these kind of repetitive jobs and do them extremely efficiently, that when a human does it, we are expected to work like them? I don't know what you think about that, Jeremy.
Well, I mean, the Amazon case is really interesting because actually, so Amazon have bought a company called Kiva Systems, and they are essentially a company where you have the robots essentially moving around the shelves in the warehouse. And so in Amazon warehouses now, and in future some other logistics systems, you're going to have robots carrying the shelves around so that the pickers can operate more efficiently. Now, if you can then solve problems in robot manipulation, you can then take a number of those picking jobs from people, and obviously that means fewer picking jobs, but then there'll also be new jobs in terms of maintaining the robots and in terms of, maintaining the warehouse. And so it's a question of the kinds of jobs that people are going to be doing. And the interesting thing is how they're going to interact with the robots, because what you want is an interaction that's going to be productive for the human, because actually if the human's not happy, they're not going to work well.
I have to say that Amazon did refute this charge that it was exploiting its employees, and that it said that the safety of employees was its number one priority and that they adhered to all the regulations and employment laws. But I wanted to ask you, Kathleen, are you worried by this sort of interaction between robots and employees in a situation like Amazon?
I thought the case was absolutely fascinating this week because it was one of the first times that I've actually heard the term robot used as its proper meaning, as a human being that is just made to labour. It reminded me of a paper in 1910 called The Principles of Scientific Management by Frederick Taylor. And basically, it's an argument that you can't really rely on individual workers' initiative. So what you need to do is develop scientific principles of management, and the managers themselves would divide the work into little pieces and then time each individual part of the work and then decide how much work every single individual worker should produce.
Geoff Pegman, do you look at that and think, gosh, I can see points now where humans and robots are going to start to conflict?
No. I think we've come a long way since Taylor in general.
Okay.
I think one of the problems that you've got is that we aren't actually using enough robots, that we still have a lot of dull, dirty, dangerous tasks that we ought to be actually getting robots to do more of. The whole idea is to try and, if you like, emancipate people so that you can actually get the people actually having more satisfying jobs. Of course, it will mean structural change, but it's about making them easier to work with people or easier to operate and to actually work in a more symbiotic way with people. Yeah.
I think one of the really important things to get across to your listeners is, when you say robot, what we think of is, as we were talking about earlier, android, a humanoid. And actually, that's neither the way that the technology, nor the economics, nor probably the social forces will drive us. So, for example, one of the things that's going to hit us in the next few years are self-driving cars. I mean, they're already out there now. That can be enormously enabling. I mean, imagine if you're essentially functionally blind or motor disabled. Well, you can't drive. Well, now the technology's out there that you can drive.
Well, let me just go back to one point, because there is this perception that robots don't create jobs. Geoff Pegman, you must get that in your line of work, people saying, you're in the business of destroying jobs and giving them to robots.
A little bit, but to be quite honest, the studies that have been done tend to support the fact that robots tend to create about 3 jobs for every robot that you put in.
How though? Give me an example.
The general mechanism is through wealth creation. I mean, robots are are more efficient at doing the jobs that they do, and therefore they tend to create wealth which actually is then used to actually expand a business.
Robots tend to realize the wealth that's in them. The reason why we don't have robots in most, Japan is the most highly intensive robotic industrialized nation, is because they're just too expensive. It is still more profitable to employ a human being, which I believe is a very unique and amazingly complex person. We have vision, we have bodies, we can navigate all kinds of different spaces. All these capabilities that human beings have. It makes sense for employers to choose those over robots.
But Geoff Pegman, is that going to change? Is that something that's changing?
I mean, if you think about a general purpose machine, yes, they're always going to be too expensive. But there are lots of examples of special purpose machines. I mean, a robotic milking machine. Believe it or not, that's one of the biggest selling...
I've seen one. I went to a ploughing conference in Ireland and I saw a robotic milking machine, yes.
Well, that is one of the big, sort of items that actually sells. The farmers like it, not only because they actually don't have to get up at 4 o'clock in the morning to milk the machines, but also they actually get more milk because the cows actually go along and milk themselves.
Yes,
effectively.
Extraordinary. I remember seeing cows queuing up to have themselves milked by the milking machine. It was quite disconcerting, actually.
Yeah, it is. But what we're going to see is we're going to see more and more of these specific purpose machines actually in different niches all over the place.
Yeah.
Jeremy?
Absolutely. I mean, another thing about technology in general is that it's always disruptive. It always has a period where people are shifting from one kind of pattern of work to another. So we're going to have those disruptive technologies, but eventually we'll pass through that. And actually on the way, we're going to create a lot of new jobs as well. So I'm more of an optimist, I think. I think I'm with Geoff on that one about how it's going to change us. I think the interesting question is, how do we want to work with robots? We had this big wave of industrial robotics in the 1970s and 80s, and that completely revolutionised the manufacturing industry. And now we've got this new wave of robotics which has come in the last 10 years, which is getting the robots to be able to cope with uncertainty. What we haven't cracked yet, and what will be a third wave, is when we can crack manipulation, which is what we do with industrial robots, but under uncertainty.
Coming very close to sort of mimicking human behaviour then. Very, very close. But I wanted to come to that point in just a moment.
Sure.
We're just going to take a quick break here. You're listening to In the Balance from the BBC with me, Manuela Saragosa, and my guests, Dr. Kathleen Richardson, Professor Jeremy Wyatt and Geoff Pegman. Now, you might think, despite what you've heard so far, that there are some things a robot will never be able to do. Laugh at a joke, for instance. Develop a sense of humour. Tell a joke, even. But you'd be wrong, because while doing my research for this programme, I came across several articles saying that the University of Edinburgh's School of Informatics had developed a computerised comedian, one that writes its own one-line jokes, which means that even our resident management consultant turned stand-up comic Colm O'Regan isn't safe.
My wife and I are halfway through Series 1 of Battlestar Galactica on Netflix. It's a TV series that tells the story of humans who created sentient robots called Cylons that eventually try to destroy humanity. There are lots of fraught questions about whether the Cylons have real feelings. Their motivations are as yet unclear. I'd look up their motivations on Wikipedia, but then I'd spoil it for you and possibly damage my marriage. In today's Netflix world, skipping ahead in a series without your significant other is nearly as bad as infidelity. One thing is for certain, the robots in Battlestar Galactica are very advanced and can do nearly anything humans can. All of which raises some extremely important questions. And I'm sure you will agree the most earth-shattering of those questions is, can a robot be a successful stand-up comedian? Look, I don't want to give away the secrets of the comedy circle, but, and I'm whispering it low, a robot could do most of my job with some basic programming. And I could write the programming now. Step 1, approach microphone. Ask, are there Americans in? If no response, then reply that you knew there were no Americans in because they would have whooped and hollered. If there is a response, then reply that you knew they were there because Americans are so positive. Make reference to their good teeth and hair. If the current American president is a Republican, say the president's name and most European audiences will just laugh automatically. If the president is a Democrat, joke about how he has Irish cousins. Use your sensors to analyse body language. If two people are seated close enough together, then suggest that they are a couple. If not married, suggest that one of them proposes right now. The audience will start cheering. Then talk to the American again. See? Easy. So far, so binary. I could probably send the Colmtron 2000 along to most gigs. But there are some things that happen in comedy that I just don't think a robot could respond to. Would a robot know when to physically intervene when trying to wrestle an unhinged audience member off the stage who is attempting to assault another comedian, and doing this without the use of lasers? Or what about if a drunk had fallen asleep while reading a book in the front row at the gig and then woke up suddenly and asked out loud, "When are the band coming on?" To be honest, I think my job is safe enough for the time being.
I think you might be right there, Colm, for now at least. Back to our guests, and we may laugh, but it does raise the important question, that piece, about how close to a human a robot can be, and whether really that is the ultimate aim of robotics, to create something that is as human as possible. And I can see you're looking at me, Jeremy Wyatt. You don't look convinced.
I suspect there'll be some people who want to do that. I don't think it's where the majority of the impact in our lives is going to be. Because I don't think people would necessarily readily accept it, and B, I don't think it's necessary, and it's a much harder path for us. It's going to be a very expensive, complicated, unreliable machine that we're going to build, and why would anyone want to do that for practical tasks? And one of the interesting things was, so when Fukushima happened, and the Japanese obviously are very well known for their humanoid robotics program, actually the Japanese had to ask the Americans and the Brits to come in with flying robots because they'd spent a lot of their effort on the humanoids, and they weren't any use for the task of finding out what was going on in Fukushima. So the thing about the humanoids is that they are this kind of strange experiment. I think particularly in Japan, they're pursued because it's seen as something that's kind of culturally or sociologically desirable, rather than that it's necessarily economically a good idea.
Well, let me ask Kathleen, do you think that is ultimately what a lot of robotics is aiming at? I mean, I know, taking into account of what Jeremy said here, but that a lot of this technology is aimed at ultimately producing something that is almost human-like.
Yes, I must say I agree with a lot of Jeremy's points there, and my interest as an anthropologist is to look at what's called a social robot, which is often given a humanoid form, and this social robot is designed for many areas of our lives. Like my last research project was looking at the use of robots to therapeutically help children with autism, and some robots are being developed for help adults with Alzheimer's or other people with different kind of disabilities, and even human loneliness. Now people are considering, how can we develop a robot to help people with their anxieties and their frustrations at human life? And so yes, I think regardless of whether humanoid and social robots work, there is a lot of investment in them because they are being seen as fulfilling all these plugs in social life.
Geoff Pegman, I mean, is that something in your line of business, as a managing director of RU Robots, that you are seeing a sort of demand for more human-like robots?
Frankly, no. I mean, ultimately, you actually have to sell these devices, and I'm talking about the new ones as well. And it is much easier and much cheaper to build something that's actually dedicated for a particular purpose. There are certain things, like, as Kathleen mentioned, social robots, where it might be more acceptable to have them in a sort of human form, and that's fine. But why would you actually build a robot that was identical to a human? Because you could use a human and it would be a lot cheaper.
Just finally, as a final thought, start with you, Jeremy. Where do you think development and research should be now when it comes to robotics? What would you like to see moving forward?
A robot can't change the world around it unless it can pick up things and move them around, right? And being able to do that in a controlled environment is a solved problem. But being able to do it in an unstructured environment, where the robot has to sense and then reason, that's really still a massive open problem for us. We're going to crack it. It's going to come. We're making steady progress is being made, and when it comes, it will transform all of our lives. But what people are actually going to see in the next 5 to 10 years, the other part, is to exploit all the stuff that has already been done in the labs, funded by all these different kinds of research programs. And that's really about bringing autonomy into mobility.
And Geoff Pegman, what do you think?
Yeah, I mean, I actually agree with what Jeremy said there, but I think autonomy is the big thing that we're going to be pushing for, together with actually interaction with people.
Yeah.
The way that the robots will interact will actually get much richer will actually become much more complex. And I think the big challenge, if you like, is then how do we actually use those robots to actually get the most out of them for the people that are actually using them.
Absolutely.
And Kathleen Richardson, what would you like to see happening in terms of robotics development?
Well, I actually think the reverse is going to happen. So the more that people interact with robots, the more that humans will have to simplify their social interactions to adapt to the machine. So when you're in a kind of environment with a machine, it can do certain things, but you yourself as the being interacting with it will be, if you like, shaped by that interaction in that moment with that physical entity. And so therefore the complexity of the human being starts to mirror the simplicity of the machine.
So we're dehumanising ourselves.
I think the reason why we see a rise in robots is because we're more and more comfortable with the kind of mechanisation of human social life.
Well, I think that's a whole other debate, and the robotic clock here tells me that we've run out of time. So let me thank you all for taking part in this discussion. Dr. Kathleen Richardson of the University College of London, Professor Jeremy Wyatt, Professor of Robotics and Artificial Intelligence at the University of Birmingham, and Geoff Pegman, Managing Director of RU Robots Limited here in the UK. Thank you to all of you for taking part. If you've got views on the programme, then do share them with us. Our email address is world.business@bbc.co.uk, or get in touch via Twitter on our Twitter feed @BBC Business, or my own Twitter handle @Manuela BBC. And I think I can confidently say we'll be back again next week. A programme presented by a robot is still some way off. So until then, thanks for listening.